Alright, so today's video we're going to be talking about quadratics, the quadratic formula again, but this time we're going to have complex solutions. And complex solutions are when we have an imaginary part and a real part. So as you can see here, I happens whenever we have a negative under the square root. And when we have complex numbers, we have a real and an imaginary part. So it's important to remember that real goes first, plus your imaginary part goes last. So as a refresher, what I'd like for you to do is try these two problems. I want you to write the complex number in standard form. So remember that the square root of negative 16 is the same thing as square root of 16 and square root of negative 1. Okay? So the square root of 16 is really 4, and the square root of negative 1 is really I. So we have 10 plus 4i is the answer to the first question. Over here, the square root of 81 is 9. The square root of negative 1 is I, so we have 5 minus 9i, and that's the answer to the second warm-up problem. So we're going to use the quadratic formula to find complex solutions. These solutions happen whenever you have a negative discriminant. Remember, your discriminant is b squared minus 4ac. If I get a number that is less than 0 or negative, I'm going to end up with two complex or imaginary solutions. Alright, so we're going to use the quadratic formula just like we always do. We have a equals 1, b equals 3, and c equals 3. Since this is already in standard form, I don't have to change it at all. By using the discriminant, I notice 4 times 1 times 3, whoops, let's fix that, that I get negative 3. And because I have a negative 3, it means I'm going to have two imaginary solutions. Okay, so what we're going to do is we're going to take the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. Now remember, this formula will be given to you on the formula sheet, so it's not that big of a deal to memorize it. So remember that this is actually two different parts. You do one with the plus, and then you do one with the minus. So you're going to plug in 3 for b, 1 for A, and 3 for C according to what we found here. Now what's going to end up happening is when you type in your calculator, you're going to get like domain error. The problem with that is because there's a negative under the square root. So let's do this. Negative 3 plus or minus the square root, and then 2a is 2 times 1. Remember when we found the discriminant and said negative 3? Instead of typing the whole problem in the calculator, just put negative 3 here. This problem looks a lot more manageable now. What we can actually do, I'll slide down, is that this negative 3 plus or minus, and this is I square roots of 3 over 2. That right there is your final answer, because I cannot simplify. There's no number that goes into the negative 3, square root of 3, and 2 evenly. The square root of 3 is irrational because square root of 3 cannot be simplified. It's not a perfect square. So the only thing that I am allowed to do is take this negative and pull it out of the radical sign by making it an I. That's the only thing I can do. So by finding the discriminant first, we actually shorten the length of a quadratic problem. So let's do another example. A is 2, B is 4, and C is 3. So taking this information, let's go ahead and find the discriminant. So I have 4 squared minus 4 times 2 times 3. And what I get is a negative 8. So I'm going to have two imaginary solutions here. Alright, so we have negative b plus or minus the square root. Now we already found the discriminant to be negative 8, so there's no point in plugging in b squared 4ac again, all over 2 times a. Alright, so what this turns into being, whoops, and I went too far, so I'll slide up. So we have negative 4 plus or minus the square root of negative 8 over 4. this square root of negative 8 can actually be broken down. So what I would do is type the square root of 8 in my calculator. And when I do, I get 2 square roots of 2. The negative also mean that it's going to have an I in it. So what we have here is negative 4 plus or minus 2i square roots of 2 over 4. Now you may think that you are done with this problem, but you're actually not. Look at negative 4, the 2i square root of 2, and 4. I notice that a 2 will go into the negative 4, the 2, and the 4. So this becomes a negative 2 plus or minus I square roots of 2 over 2. Okay, notice that the square root of 2 did not change to 1. It's under the radical, whereas all of the other three are not. So your final answer is actually negative 2 plus or minus I square roots of 2. Alright, so let's try another problem. Why don't you pause and give this one a shot, and then unpause when you're ready to see if your work is correct. Alright, so we get an A of 4, a B of 16, and a C of 21. So let's go ahead and find the discriminant. B squared minus 4AC is 16 squared minus 4 times 21, which will result in a negative 80. So what we have here in the negative 80 means that we have two imaginary solutions. So when we take this discriminant, we are going to plug it in right here for the B squared minus 4AC. So we have negative 16 plus or minus the square root of negative 80 over 2 times 4. So we have some simplification that needs to happen here. So negative 16 plus or minus, now negative 80, if I type it in my calculator, is going to result in 4 square roots of 5. So I typed in the square root of 80 and I left the negative alone because I know that if I type a negative under the square root, I'm just going to get domain error. So then the negative results in an I. So I have 4i, oops, let me get the right colored pen, 4i square roots of 5 over, and 2 times 4 is 8. So I notice that there is a number that will go into negative 16, the 4, and the 8. So that would be 4. 4 goes into those evenly. So negative 16 divided by 4 is negative 4. 4 divided by 4 is 1, so I'm left with I square roots of 5 over, and 8 divided by 4 is 2. So my final answer is negative 4 plus or minus I square roots of 5 over 2. Oops, there we go, over 2. Alright, so let's try the next example. I want you to go ahead and pause the video and see if you can do this one by yourself. Alright, so A was 8, B was negative 10, and C was 4. By plugging this into the discriminant B squared minus 4AC, I notice that I get negative 28. So I will result in two imaginary solutions. So a negative 10 plus or minus the square root of negative 28 over 2 times 8. Remember that the negative 28 right here actually comes from the fact that we've already done the discriminant. Alright, so I'm going to scroll down a little bit. Negative 10 is a positive 10, plus or minus, and then the square root of 28. Type that into your calculator, and you get 2 square roots of 7, and you also have an I because of the negative. So 2i square roots of 7 over, and then 2 times 8 is 16. Let me fix this 2 a little bit. That way you can see it. There we go. 2i square roots of 7. Now, the question is do we have a number that will go into 10, 2i, and 16? The answer is yes. They're all even, so 2 will go into them evenly. So 10 divided by 2 is 5. 2 divided by 2 is 1, so we're just left with the I square root of 7. And 18 divided by 2, or 16 divided by 2 is 8. I'm already thinking of the answer in my head. I do that too often. There we go. So our final answer is 5 plus or minus I square roots of 7 over 8. Now you may think that simplification is not really necessary. However, if you're given a multiple choice test, the answer 10 plus 2i squared roots of 7 over 16 is not going to be an answer because it's not in its simplest form. So if you don't automatically see your answer, it doesn't necessarily mean that you are incorrect. It means that you just need to take a look at your answer and see, can I simplify it, and then does it look like one of the other answers at this point? So you have to be thinking about your test-taking strategies as well. Alright, so that's it for complex numbers. I will see you guys later.